PulseBoard launches a popular topic and feed reads jump from 2,000 to 20,000 each second. Someone says, add a CDN. Someone else says, add Redis. A third person says, add more servers. All three may eventually help, but they answer different questions. A content delivery network serves reusable content from locations near the reader. A cache avoids repeating expensive work. A load balancer chooses a healthy application instance for a request. System design becomes clearer when every component has one stated job and one stated failure mode. Images, style sheets, application bundles, and public media are good CDN candidates because many people request the same bytes. PulseBoard puts image variants and public assets behind an edge cache with explicit cache control rules. A new profile image uses a versioned URL, so the system does not need to guess when every edge location has refreshed. The CDN is not the database. It does not decide who may view a private feed. It reduces origin work for safe, reusable content. Keep authorization-sensitive responses out of a shared cache unless the design explicitly proves the key, scope, and invalidation behavior are correct. For a popular topic feed, the application checks a cache before asking the database to build the response. On a cache hit, the request is fast. On a miss, the application reads durable data, builds the response, and stores it with a short time to live. This cache-aside pattern is simple to reason about, but it introduces a new truth: cached data can be old. For PulseBoard, a feed may be a few seconds behind while a newly created post is read directly by its author. State that trade-off in the product contract. Do not call stale data a bug if the user promise allowed it. A load balancer sits before several stateless application instances. Stateless means any instance can handle the request because session state and durable facts live elsewhere. The load balancer uses a health check to avoid instances that cannot serve traffic correctly. A process responding to a shallow ping is not always healthy. PulseBoard's check verifies the process is alive, its required configuration is loaded, and it can reach a minimal dependency path without turning the check itself into a source of load. Health checks are product decisions encoded as probes. In the local simulation, the first feed request is a cache miss and takes 200 milliseconds. The next requests are hits and return quickly. Then a synthetic post is published. One reader sees the new item through a direct path. Another reader sees the prior cache entry for 3 seconds. The dashboard labels both states. A second application node begins returning errors. The health check marks it unhealthy and the load balancer stops routing new requests to it. The remaining nodes carry more traffic, so latency rises. This is the whole story. Speed, freshness, and capacity remain connected. A cache can fail in ways that surprise teams. If a popular key expires at once, many requests can stampede the database. Use short jittered expiry, request coalescing, or a controlled refresh for hotkeys. A load balancer is also a dependency, so deploy it redundantly and know what happens when its control plane is unavailable. A CDN can mask an origin failure for cached assets, but cannot repair dynamic actions. Resilience is not adding boxes. It is designing how the user journey degrades when each box is slow, wrong, or gone. PulseBoard now uses a CDN for public static media, a bounded cache for high-read feed views, and a load balancer for stateless application nodes. Each choice has a measured target: cache hit ratio, P95 feed latency, healthy node count, and stale window duration. The team still has a deeper question. One database cannot serve every future read and write pattern forever. In Episode 4, we decide which data must agree immediately and which data can arrive later.